Let's solve this partial differential equation. Hello everyone, this is Aditya and today we're going to discuss this question. But before that, please do like, share, subscribe my channel and please support this video. Now let's start. So the question states that z is equal to the sum of these two arbitrary functions. So we can see that there are two arbitrary functions, which means that it will be a second order differential equation. So let's see how we solve this, and of course soon I will bring the one shot for partial differential equation also for BTech, so kindly stay tuned with the channel. So let's start. So we know that z is equal to f of x plus it, where I is equal to square root of -1 and t is a variable. It is a independent variable and z is a dependent variable, right? Plus g of x minus it, correct? Okay. So we need to eliminate two arbitrary functions. So of course we know that the degree will be 2 of the resultant partial differential equation. So del z by del x is equal to, so before that we need to make a substitution so that you don't get confused. Let's assume that x plus it is equal to u1 and x minus it is equal to u2, correct? Yeah. So we can say that z is equal to f of u1 plus g of u2, correct? We can write it like this. Yeah. So we have to write it over here somewhere so that we remember it, that u1 is equal to x plus it and u2 is equal to x minus it, right? So now let's solve this expression. So we had that z is equal to f of u1 plus g of u2, correct? Okay. So now let's differentiate it with respect to x first of all. So del z by del x is equal to del f divided by, del f divided by del u1 dot del u1 divided by del x plus del g by del u2 dot del u2 by del x, correct? Okay, I could have directly used this formula because we know that there's a formula, but I don't believe in formula. We can easily derive it also, and it is just a one-line derivation, right? So we can write it as del f by del u1 dot, what is del u1 by del x? It is equal to 1 plus del g by del u2, and what is the derivative here? It is again equal to 1, correct? Yeah. So del z by del x is equal to del f by del u1 plus del g by del u2, and we have to remember this expression. Let me write it over here so that we don't forget it, maybe somewhere here, that del z by del x is equal to, or maybe let me write it somewhere else and we will remember this. Del z by del x is equal to del f by del u1 plus del g by del u2. It won't be visible to you, but still I will use it later, so kindly remember this expression, right? Okay. Now let's differentiate it with respect to t. So del z by del t is equal to del f by del u1, correct? Correct? Just check it once. Yeah, it is correct. Simple. So del f by del u1 is as it is. What's the derivative over here? It will be I, right? Correct? And over here it will become negative I del g by del u2. Of course, when you're differentiating it with respect to t, then x is a constant, and when you're differentiating with respect to x, then t is a constant. Simple, right? Okay. So del z by del t is equal to I, we can take as common, del f by del u1 minus del g by del u2, correct? Okay. So let's remember this expression also, and let me write it somewhere. Of course, it won't be again visible to you. I'm just writing it for my reference, and you have to remember this, okay? By del u1 minus del g by del u2, correct? Simple. Okay. So let's see how can we relate those two expressions. Let's see them. So we have del z by del x is equal to del f by del u1 plus del g by del u2, right? And we had del z by del t is equal to del 2f I mean del f by del u1, of course multiplied by I, minus del g by del u2. Correct? Simple expression, right? Now what can be done next? Well, we don't see a clear relation between them. So let's differentiate it second time. Let's differentiate this expression second time. So del 2z by del t square is equal to I. Now what will be its derivative? It will be del f by del 2f by del u1 square dot del u1 by del x. Correct? Right? Okay. Minus del 2g by del u2 square del u2 by del x. Correct? Sorry, del t over here. Right? Okay. So now it is simple. It will become del 2f by del u1 square, and what is its derivative? It is again equal to I, and it will be negative I. So negative I into negative 1, it will become plus I times del 2g by del u2 square. Right? Okay. So we can take I as common. So when you take I as common, it will become I times I square. It will become negative, right? So we got this expression that del 2z by del t square is equal to this expression, right? I hope that you are understanding that what procedure I am doing. Basically, I want to create a relation between these two, but I see that there's a complex number and there's a negative sign over here, so I can't compare them. So that is why I'm trying to manipulate the things such that we make them similar. And now we can see that it is also like it does not involve a complex term over here. So we think that yeah, maybe the problem is simpler now. So we have to manipulate, we have to change this a bit. So let's see how can we do. And of course we know that it will be a second order differential equation, partial differential equation, since we had two arbitrary functions over here, right? So let's see. Now let's differentiate this expression also with respect to x. So we will get this expression is equal to del 2f by del u1 square dot del u1 divided del x plus del 2g by del u2 square dot del u2 by del x. Correct? I hope so that it is clear. It is just the chain rule, right? Whatever I am doing, it is just the chain rule, nothing else, right? So again, it is equal to 1 and it is also equal to 1. So we can just write it as 1 and as 1, right? Of course, you know, when you differentiate with respect to x, you get 1, and over here also you will get 1, right? Now there's something interesting over here. Remember that del 2z by del t square was equal to negative of the quantity del 2f by del u1 square plus del 2f by del u2 square, right? Now it is just this expression only, which means that del 2z by del t square is equal to negative of del 2z by del x square, and this is the required differential equation. Or you can write it like the del 2z by del t square plus del 2z by del x square is equal to 0. So this is the required differential equation, right? And this is the answer, right? Simple. So after that, this solution was clear, and I will bring a complete one shot on partial differential equation, right? So if you did enjoy this video, then please do like, share, subscribe my channel, and please support this video. Bye bye. Take care.